systems of equations, and when we did systems of equations, what we did was we graphed two lines, and we found that the solution to a system of equations is a point. Or if it was a parabola and a line, or a parabola or two parabolas, sometimes we had two solutions. And I think the hardest thing about systems of equations and doing it with quadratics is that we just have to switch modes. When we're doing quadratics, the solution is on the x-axis. When we're doing these, the solution is the intersection. So you have to know what kind of problem you have. Are you looking at two equations? If you're looking at two equations, then you want to know where they cross. If you're looking at one equation, then you want to know where it crosses the x-axis. But that's this unit. Okay, so today we're going to do inequalities. It's very similar to equations. But the solution to a system of linear inequalities is going to be a shaded region. So it's going to look like, today, it's going to look like this. And maybe we're shading over here for one, and down here for another. And their solution is that overlap. So we're looking for that overlap. You're going to see a lot of problems where we're going to have you like put a star in the shaded region, put a star on one of the ordered pairs, because that's what the OST has you do a lot. Remember, if you're multiplying or dividing by a negative, you have to flip the inequality when you're solving for y. And just another tiny piece of review, our less than and our greater than symbols are graphed with a dotted line. And our less than or equal to or greater than or equal to we graph with a solid line. If you are willing to put these into Desmos, you don't have to remember those rules. Because Desmos will graph the dotted line for you. Desmos will graph the solid line for you. Desmos will graph the shaded region for you. So you just have to be willing to put it in. And that's why, if you notice, the first two problems on your notes, we're not having these solved for y. We didn't even give you a grid to do this on. Graph the following systems on Desmos. We did this earlier this year where we had you graph it by hand because graphing is an important skill. We are past that skill and on to interpreting what it means. So now, put it into Desmos. Don't have to solve for y, put it into Desmos. Just exactly the way it looks. Clear out that last quadratic you had in there, and you're going to put these right in. Exactly the way they look. My first graph came out purple. Before I go on to the next graph, I'm just looking at that and making sure, I'm looking very carefully to make sure I copied everything correctly. Negative 6x plus 2y is less than 4. I'm going to hit the home button. And then I have x is greater than or equal to 1. I would rather have a different color there, so I'm going to change that color. Maybe I'm going to change that color. Ooh, let me go green. Okay. What we're asked to check some points here. So again, our solution is this overlap. So I'm going to put these ordered pairs in there. I'm going to put them in one at a time. We're going to check 9, 2. When you put the ordered pair in, you have to put it in exactly the way it looks. 9, 2. Is it in the overlap? Yeah, it pops up in red out here for me. It's absolutely in the overlap, so that's a yes. Okay, what about 0, 0? Is 0, 0 in the overlap? It's not. It's in one of the shaded areas. But if we're doing a system, we need the overlap. So that's a no. It's only in one. So no. All right, the last one I want to look at is 1, 5. Okay. Ooh, this is a tricky one. Because it's on the point of intersection, but if it's on the dotted line, is that okay? So if those are two solid lines, it would be in the overlap. Well, it's a dotted line there, so it's a solid and a dotted. I can't remember, I don't have my notes down. So it has to satisfy both equations, and that wouldn't satisfy the dotted equation because we're not including. So because it's on the dotted line, we can't include on that one. And that is tricky. I had to think about it for a second. All right, now put that next system in. And then you can put those ordered pairs in. You can put them all in at once. I kind of like putting them in one at a time so I can focus a little better. So I'm going to pull up Desmos and get that going. Get rid of everything I had up here. Again, we're going to say about 1,000,000 times before you take the OST, double check your entry. Y is greater than or equal to 2x minus 18. Negative 4x plus 5y is less than 1. Again, we have lots of gray dots here. We don't care about gray dots if we have shaded areas. Okay? And now I'm going to put these points in at 0, negative 5. Is that in our overlap? Absolutely. That's in our, this purple point is in our overlap. Now I'm going to put in 5, 5. That in our overlap. It's in the purple but not the green, so that's a no. And 10, negative 12. 10. And some of you can just do this by eyeballing it. 10, negative 12, that's just in the green. So 5, 5 was just in the purple for me, and 10, negative 12 was just in the green. So again, with systems of inequalities, we're just looking at shaded region is what we're looking for. Questions about those two problems? Yesterday was point where they cross. Today is shaded region. The rest of the unit is going to be point where they cross, which is nice. Now we're going to write the system of inequalities. So this is like yesterday. You guys did a great job with this yesterday. The only thing that's different from writing the equations yesterday is that instead of an equal sign, we need a symbol there. So I still do a fill in the blank, which you guys did great yesterday. Those of you who turned in that half sheet practice, it was lovely. I'm going to do the downhill line first. So if I look at this downhill line, what's my y-intercept? 5. And it's a positive 5. So if you're doing this fill in the blank, the only thing I saw that wasn't perfect on the practice was just leaving out a sign if it was positive. Make sure you put a plus there. And our slope, it's a little harder to tell with dotted lines, but here we're coming down and over. We're going down 1 over 2, so my slope's negative 1/2. And now with an inequality, we have to decide how to deal with the shading. Here we're shaded below. So this is going to be a less than, y is less than. And it's a dotted line, so we don't want it equal to. There's the equation for you guys in the back. I haven't been able to see that well. For equation number 2, we're going to do the same thing. Our y-intercept is -1. Our slope, we've got lots of nice points here. I'm going up 1, right 1, so it's 1 over 1, or you could just write it as 1. We have a solid line, so I need an equal to. And again, we're shaded below. And if you ever need help, I know sometimes our copier doesn't do a phenomenal job of showing you where the shading is. So if you're ever unsure about where the shading is, just ask. So again, we're shaded below, so we're going to do less than. Yep, less than or equal to. And then you can check this in Desmos. Put it in Desmos and make sure you get the same picture. You can always do that when you're writing equations. I'm actually going to save a little time so you guys can get to the practice, and we'll do that. We'll check it on Desmos on the next one. Are you okay with that? Any questions about writing those equations? Okay. Again, we're going to write a system of inequalities. We're going to say which are solutions. We're going to graph it in Desmos to check. I'm going to start with the downhill line first, but before I do anything else, I'm going to write that fill in the blank. My downhill line has a y-intercept at -4. And the slope, if we look at where to put points here, yep, down to right 1. And you can write that as -2 over 1 or just -2. So it's hard to tell where it's shaded. The purple is shaded, and I started the y-intercept and basically look up or down, like where is it shaded? It's kind of a good middle point. But you can go to any point and just go straight up on the grid or straight down on the grid and see where it's colored in. Here we're above, so we're going to be greater than, and since it's a dotted line, we're not going to use that equal to. For the gray line up here, it has a y-intercept of 1. So I'm going to put +1 in there. You have to have that symbol, otherwise it looks like multiplication. So it's a +1. And then the slope here, there's the next nice point. I'm going up 2 and over 3. So that slope is 2/3. And then this one is shaded below, and there's a solid line. So we're going to do less than or equal to. The shading's down here. And it's a solid line. So we can put this into Desmos to check it, but you can put these points on. 0, 0 is right here. That is absolutely in our overlap. 3, 3 is here. It's on the solid line in our overlap. So 3, 3 is a good point because it's on the solid line and not the dotted. -3, 2, if I go -3, 2, I'm on the dotted line. And dotted line is a no. And 1, -4 is in our overlap. Again, the way to check these is to put your equations into Desmos. It's really easy to leave out a negative or to have a sign or symbol flipped around. So it's really important on our tests, but I think even more so on the OST, to make sure you're checking your work. So the way I wrote it as -2/1 x minus 4. And I'm just going to check, like this point right here is at -4, and I have a downhill and a dotted line. So this point right here is at -4. It's downhill and a dotted line, so I feel pretty good. My other equation is y is less than or equal to 2/3 x plus 1. Oh, hello. I put that in all kinds of wrong. X plus 1. That's going through at 1. It has a solid line. It's an uphill. I'm pretty confident this picture matches that one. Feel pretty good about that. We have one more problem to do together. Again, check on Desmos. This last one, it says, which graph represents the solution of these two inequalities? This is a released OST problem, I believe. This was on the OST. The nice thing about this problem is you'll notice the lines are all the same. So this problem is not testing you about whether you know how to graph a line. This problem is testing you about the shading. And so you can absolutely, here, this should be the x plus 3 line you should shade under, because it's less than. It should be a solid line because it's equal to. This one you should shade above because it's a greater than, and it should be a solid line because it's an equal to. So all of those are solid lines, so this is just about shading. So I would put it into Desmos to check it. I think that is what makes the most sense. So I have y is less than or equal to x plus 3. And you're welcome to do it by hand. And I have y is greater than or equal to -2x. Is it plus 2 or minus 2 up there? Minus 2. So if you look here, the shading is over here, like you have your lines crossing, and the shading is over here to the right. So I want to find and you could even sketch that, like here's your x, and there's your overlap. Which one looks like that? B. And just like we said for this equation that starts at 3, we should shade under. So this guy is shaded here. And we said for this guy here, we should shade up. And that one starts at -2. So there's your line, and you're shading up. And so there's your overlap. So Desmos, or do it by hand and check it. Now you, this. Please.